Okay, having a look at our Unit 1 Week 3 quiz for maths methods. We're looking at, to start with, our interval notation. So we've got some images here that we want to convert into into interval notation. So the first one we can see is going between -3 and 2. Now we then have to decide on our type of bracket. So that 3 is a solid circle, the -3, so we'll do a box bracket. The 2 has an open circle, so we use a curved bracket. Now part B is a little bit different in that we've got between -infinity and -3, but we also have between 1 and +infinity. Now we want to represent that in like interval notation, so we don't want to do it as two separate parts, we want to do it as one. So if we write -infinity, -3, and then say it's the union of that set and 1 +infinity, then we're bringing those two together. In the second question, we've got our universal set, then we've got A, B, and C. And the first question is A union B, so we're looking at everything that is in A and also in B. So we've got 1, 2, 3, 4, then we've got 2, 3, 4, 5, 6. So that one's just going to be 1, 2, 3, 4, 5, 6, because that's everything that's in A or B or both. The next one has not A and B, so the overlap between not A and B. So if we're looking at A, it's 1, 2, 3, 4. So the not A is going to be 5, 6, 7, 8, 9, 10, 11, 12, 13. And the overlap with B, it's got 2, 3, 4, 5, 6. So the overlap is just the 5, 6. Then we're looking at some surds. So we need to simplify our surds. We've got 4 times 3 gives us 12, and then we can bring the two surds together. So we'll write that as the square root of 10, because 5 times 2 is 10. Here we've got -2√3 cubed. So we've got -2√3 being multiplied by -2√3 being multiplied by -2√3. Now -2 times -2 times -2 is the same as -2 cubed, which is just going to be -8. And then you've got √3 times √3 will give you 3, and then you're multiplying that by another √3. So we've got 3√3, which we can then write is -24√3. Then for number 4, we're simplifying, so we're collecting our like terms. So here we've got √5, and then we've got -3√5. So overall that will be -2√5. Then we've got 3√2 plus 7√2 is 10√2. In part B, we need to break it down a little bit. So 54 we can write as √9√6, because 9 times 6 is 54. Then we've got the 3√18, so we could go 3 times 6, or we could do 2 times 9. I'm going to go, I'm going to go the 3 times √2√9, and then I've got the -2 times 294. So we want to go, well, what goes into 294? We're looking for a square number. So does it divide by 9, because our other ones have? No. Does it divide by 16 maybe? No. Does it divide by 4? No. Does it divide by 36? No. So we're just going through all our options. Probably should have just started at 4 and worked our way up. So we've tried 4. Then we try the next one, which would be 9. Then we try the next one, which would be 16. Then we try the next one, which would be 25. Then we try the next one, which would be the 36. Yes, we've already tried that. Then we will try the next one, which would be 49. And we get a 6 there. So we've got 2√49. And then that is the 6 there. And this is where I could have gone the √6 option there so that I could collect the √6. So I could have gone here 3 times √3√6, and then I would have a √6 for each of these. So then I've got 3√6 there, and then I've got 2 times 7√6 there, and so I've got my to get a 2 times 7 is the 14 √6, 3√3√6, and 3√6 there. And then I could go and bring those together and say that I've got the 3 plus the 3√3 take 14 being multiplied by √6. So that's one option. Or I could have stuck with this one up here, reduced that to 9√2, and then collected the root 6's there. When we get to our simplifying, so number 5, it is a bit of a tricky simplifying one. So we've got our root 3 over 3 root 3 plus 4. We want to rationalise the denominator. So to get rid of that on the bottom, I need to have on the top 3 root 3 take away 4, because I'm doing that technique where I'm using difference of two squares to get rid of the square root signs on the bottom. 3 plus 4, because when I expand that out as a difference of two squares, I'm going to get 3 root 3 squared, which is going to be 9 times 3, which is 27. And then I'm going to have minus the 4 squared, which is 16. So I'm just squaring each of those and doing difference of two squares. And then the 27, take the 16, just gives the 11 on the bottom. And then here we'll expand that out. So 3 root 3 times root 3, the root 3 times the root 3 will be 3. So you'll have 3 times 3 is 9. And then you've got 4 root 3 on the top there. And you leave that answer. With this part B, what we can do is we can rationalise each one individually and then bring them together. So we can do the 5 over root 5 minus 2, and then multiply by that root 5 plus 2, and then that would be the root 5 plus 2 on the top there, and then we would have the plus, and then that one would be 2 root 5 on root 5, and then that would just give you a root 5, sorry, and that would just give you 2 root 5 on 5, and then here you would end up with the 5 root 5 plus 10 over, and then root 5 squared would just be 5, minus 4 is 1, 5 root 5 plus 10 on 1, plus 2 root 5 on 5, and then to get the same denominator, we can times this one top and bottom by 5, over 5, plus the 2 root 5, and then bring that together. So we'd have that all over 5, and we would get the 25 root 5 plus 50 plus 2 root 5. So then we can bring that together and make that 27 root 5 plus 50 over 5 as our answer. Going on to the second page, we've got some quadratic questions. So we've got a parabola, has x-intercepts of -1 and 2, and passes through the point 3, 6. So straight away, we can use our a outside of x minus e, x minus f, where the e and f are the x-intercepts. So we've got a outside of x plus 1 and x take away 2 there. Now we're given this point 3, 6, so we can sub that in and say 6 is equal to 3 outside of x plus 1, x take 2, but we know the x is 3, so I should have had a there, sorry, a outside of, then I've got a outside of 3 plus 1, 3 take 2, now 3 plus 1 is 4, times 1, so I've got 4a is equal to 6, so my a is equal to 6 on 4, which is the same as 3 over 2, and then I can put that back into the equation of 3 and 2 outside of x plus 1 and x take away 2. Then question 7, completing the square. So we're looking at these first two, and we're saying if I've just had that, disregarding the plus 6 there, I would say that that would be x plus 2 in the bracket squared. When I expand that, I would get x squared plus 4x plus 4. Now I've got a plus 4, but I want it to be plus 6, so I need to plus 2. So then I'm just going to make that x plus 2 squared plus 2 as my answer when I've completed the square. The next one, I'm determining the x-axis intercepts. Now that's when y equals 0. So I've got 0 is equal to x squared plus 3x plus 2. I want to try and factorise that. So what two numbers will multiply to give 2, but add to give 3? So they will be 2 and 1. So I have x plus 1, x plus 2 equals 0, which means x must be equal to -1 or -2. For this one over here, I can say that 0 is equal to 9 minus x squared. I can do it as a difference of two squares if I want and go 3 minus x, 3 plus x, therefore x is equal to 3 or -3. Or I could take that x squared over and make it x squared equals 9, then do the square root of both sides. Square root of 9 can be plus or minus 3. Then we've got determining the x-coordinates of the point of intersection of the parabola y equals 2x squared plus 3x minus 5 and y equals 2x. So we could do that algebraically and go 2x is equal to 2x squared plus 3x minus 5. Take that over and get 2x squared plus x take 5, and then try to factorise that. It doesn't factorise, so we would have to use quadratic formula. Or the other option is to pop that into your calculator. So we've got y equals x squared, what is it, 2x squared plus 3x take away 5, and then we have 2x as the other line. We will graph that, and we can see that it intersects at 2 points. We can use our intersect function on our calculator, enter, enter, enter. It got me this one up here, so the 1.3507811, and the y, we're only wanting, oh no, we want the points, so we want the coordinates. So the 1.3507881 and the 2.701, and then to get the other one, we put our trace on, and just make sure our cursor is sitting as close as we can to that intersection. Then when we do that, we can see the other one at -1.85 and -3.70156. Now lastly, we're just wanting the coordinates of the turning point. So we know in turning point form, we have x minus h squared plus k. Because we've got a plus there, that means our x coordinate is going to be -4, and then we have the -6. And then for the second one, we've got our -6 there, so that'll just be the 6, and 4 for the second turning point. And that's the revision sheet.